Kia ora. In this video, I'm going to try to work through questions 1A, B, C, and D from the Level 2 Algebra exam from a couple of days ago. And there are a couple of ways to do some of these problems. So this video will probably go right up to 15 minutes, or I might have to split it into two parts. So the first question is your classic beginning logs question, which if you're good with powers of numbers, you should be able to do without a calculator, but I'm going to do this question in two ways. So I've just written it out first with the log on the left-hand side. Obviously it doesn't matter, but for me, I usually, when I'm first teaching logs, I usually teach students how to do the loopy thing with the log on this side. Now, it's fine if you're good with it both ways, of course that's fine, and most of you will be, but for me, this is how we start off doing logs, right? So we have 5 to the power of x is equal to 625. If you know your powers of 5, this is one that you can do straight away and get to x equals 4, because we have 5 squared is 25, 5 cubed is 125, and 5 to the power of 4 is 625. Now, if you couldn't do that straight away, there is a way that you can do this by taking logs of both sides. So we would go like this. And this log here, I haven't written it with a base, which means that it is implicitly base 10. So we're going to apply our log rules, and we get x log 5 is equal to log of 625. So x is equal to log 625 over log 5. And now you can bung that in your calculator and you'll get out x equals 4. Okay, but hopefully most of you didn't need to do that, because that's actually quite a lot of work for the very first question. So most of you probably figured out that 5 to the power of 4 is 625. Right, let's look at question B. So B is a lot like a level 1 in a level 1 make the base the same question. The only thing is that it's got a negative power hiding in here. So that's what makes it a level 2 question. We can see that here we've got 9, so we're going to change the 9 to 3 squared to the power of 2x plus 3, and 1 over 27 is equal to 3 to the power of negative 3 to the power of x. Expanding the brackets gives me 3 to the power of 4x plus 6, and on the right hand side I get 3 to the power of negative 3x. Okay, I'm just checking that before I go on any further, right? So I've got this 9 I've changed over to 3 squared, and this is 1 over 3 cubed, which is how come it's 3 to the negative 3. Now we can equate the powers because I've got the same bases. So 4x plus 6 is equal to negative 3x. 7x is equal to negative 6, giving me x is equal to negative 6 over 7. And if you had time, you could go back and you could check that that worked again in your calculator, or not in your calculator. In fact, I'm going to do that check now. So 2x plus 3 will give me negative 12 over 7 plus 21 over 7, which is 9 over 7. So that's that power. So 3 squared to the power of 9 over 7 is equal to 3 to the 18 over 7. That's on the left-hand side. On the right-hand side, we have 1 over 27 to the power of negative 6 over 7, which is the same as 27 to the power of 6 over 7, which is equal to 3 cubed to the power of 6 over 7, which gives me 3 to the power of 18 over 7. So that equals the left-hand side. Now, you totally do not need to do that in the exam, right? But that's just how we could go back and check that we'd got the right answer. Okay, so we're going to delete all of that, not necessary for the level 2 paper, unless you are really feeling like making sure, not just with your calculator, that you've got the right answer. Right, on to question C. Well, we've got two different logs. We've got the log to base b of x is equal to 2, and the log to base 3b of y is also equal to 2. And we have to write y in terms of x. So that means that we need to end up writing y equals blah, blah, blah with x's in the expression. So a good place to start would be by undoing the logs. So we're going to do the same as what we did before. we get b squared is equal to x, and 3b to the power of 2 is equal to y. Right, the base here is 3b, so that's what's getting squared. So that gives me 9b squared equals y, and b squared is the same as x. So we can take this and we substitute the b squared in here, and we get 9x is equal to y. Okay, so we're done. Now on to question D, which will be a merit question, I think. I'm not sure exactly how they'll mark this paper, so that's why I'm not talking about what's what. But this one here is a quadratic formula question where they have told you to solve this using the quadratic formula. So that's a nice hint. Let's just have a read. Right, using the quadratic formula, find the fully simplified solutions to the quadratic equation in terms of k. So we're either going to end up with 0, 1, or 2 solutions. We start off and we've got a equals 3, b equals negative 4k, and c is equal to k squared. So our quadratic formula gives me x equals negative b plus or minus b squared minus 4ac over 2a. Substituting in and checking when I finished it, I get negative b, so 4k plus or minus negative 4k squared minus 4 times 3 times k squared divided by 2 times 3. Right, let's just go back and check that we've substituted correctly and that we've done the a, b, and c correctly. Right, so a is 3, b is negative 4k, and c is k squared. I've written out the quadratic formula correctly, and now I'm going to start substituting. So b is negative 4k, so this one is 4k. The big thing to watch in this question is that when I square negative 4k, it's got to be in brackets. Okay, it's negative 4k times negative 4k minus 4 times 3 for a and k squared here. Some of you are probably watching and going, why is she going so slowly and checking? It's because over many years I've made so many mistakes in substitutions that could have been avoided, and most students that I teach have as well. So that's the motivational speech for the day. Okay, 4k plus or minus the square root of 4k squared divided by 6. Now the square root of 4 is 2, and the square root of k squared is k. So that's what we've got there. I can divide everything through by 2, but I'm not going to do that actually. I'm just going to get on with it. Right, so I've got two outcomes here. I've got the plus 4k plus 2k over 6, or 4k minus 2k over 6. Now you could have divided out your 2 here, but there's not much point. So here we've got 6k over 6, or 2k over 6. So x is equal to k, or 1/3 k. Okay, so that's my final answer there. Obviously, it is completely fine to write that as k over 3. By now, I'm sure that everyone watching this knows that they are the same thing, right? A number divided by 3 is the same as 1/3 of a number. So there you go. I'll try and do the rest of the algebra paper over the next day or two. If you've got any questions that you really want to see in a hurry, just shoot me an email, either for algebra or calc. I haven't looked at the probability paper just yet.